All right, couple record keeping things before we start. So your final exam is on Thursday the 14th from 10:50 to 1:20. So it is a little earlier than this class normally is. To be exempt from the final, you have to have A's on all your tests and 80% of your ALEKS done. I will let you know next Tuesday as long as you've met the criteria for the tests. And as long as you met the criteria for the tests and you hit the 80% on the ALEKS, you're fine. You don't have to tell me. I'll notice that before the final starts to make sure to know you're not going to be here. Not a big deal. If you do not qualify for that and you take your final exam, I am setting up. So your final exam can replace your lowest test grade. So say you got a 60 on one of your tests and you get an 80 on the final, the 80 will replace the 60. So that can also improve your grade. Yes, question about the final.
What if we have a class?
You do not have a class at that time.
Oh, and my other class knows about this?
Yes, your other class has a different time.
All right.
So the final schedule was designed so that your other class the class before this, most likely you have the test on Tuesday. So they're broken down. So all you will not have your normal classes the week of finals. They will all be odd times based on that because they expanded and gave us 3-hour blocks to do our tests basically.
Will my other class be before its normal time if I have it that day?
It's if you hold on a second, I can
work Thursday.
That's fine. I can actually tell you. What was your other class this time?
11 to 12:15.
Your test is on Tuesday from 10:50 to 1:20. So you have that final on Tuesday the 12th. So it works.
That class said that they don't have class on Thursday.
Right. They won't have class on Thursday the 14th. You'll only have it on the 12th. Yes. Yep. We've never had a finals week before. This is brand new.
This is so I can still come in at 10:50.
Yes, exactly. All right. So that takes care. Any other questions on the final? Yes.
When's the last day that we have all of our ALEKS?
The day of the final, the 14th. I'm going to check Friday the 15th that morning to do my final grades. Any other questions on the final, that piece? All right. Second, housekeeping thing. I got my schedule for this spring. I'm teaching the Calc 1 class at 9:30 on Monday and Wednesday. So if you've signed up for that class, congratulations. You're one of the 28 that got in. It is currently full. I do not know the procedure. I don't mind over-enrolling at a couple students because I know people are going to drop anyway, but I don't know the procedure on if there's a waiting list or anything else along with that. So if you talk to your advisor and they go, yeah, you just need the teacher's approval to get in, come see me. I'll sign off on a few people. That's not a big deal. However, if you were not able to get into that class, you do still have full access to my website. It never goes away. So on Mondays and Wednesdays when I teach that class, my notes will be posted, my class lectures will be posted. It'll all be there. So you can easily go back and use that as a second resource to whatever class you're currently taking for Calc 1. I'm also here on Tuesdays and Thursdays from 5:30 because I have my Calc 2 class. So I will probably have my office hours before that class anyway. So if you were taking the other Calc 1 class that's on Tuesdays and Thursdays at 5:30, if you would like extra help, I'll probably be here about 4:30, and I can help you out before your class at that point as well. So those are two options for you if you're taking Calc 1 in the spring, to still get some help from me at that point. That's that piece. Any questions about that? I also have left ALEKS open. So all the topics and everything else will be open until the 15th of January, which is right before the spring semester starts. So if you want to continue to practice the algebra and stuff like that in ALEKS till your Calc 1 class starts, you have full access to do that as long as your ALEKS subscription doesn't run out. So you'll still have access to that. I will tell you the number one mistake and problems that people have in Calc 1, as I've been saying all along, is algebra-based. It is not calculus-based. So really practice and hone your skills on the algebra stuff and things like that, and you will do fine in your calculus class. So, all right. Yes, any questions about that?
So you said the topics are available till January.
Yeah, I'm going to leave Alex open. That's not going to count towards your grade. Your grade closes on the day of the final, the 14th.
Right.
But I'm leaving it open for people to go back and review and practice and stuff like that to prepare for your Calc 1 class.
This is for people that are taking Calc 1.
Exactly. People who are taking Calc 1 in the fall
I
or in the
almost got
spring.
Calc 1, but I wasn't satisfied with the time, so I
So-
decided to save it for another semester.
Yeah, that's fine. So this way you still have access to practice if you want. So last piece. Next week, we don't have any new topics I'm covering next week. Next week is literally a review for your final exam. So you have a couple options. The final exam review is already online. You can practice the review test there. If you need help, come in. If you don't, you do not have to come in next week. You can use that time to work on your Alex topics and stuff like that. If you do come in, I'm probably going to do, there's 20 questions in the final. I'll probably do 10 each day, and I'll take it. If you have other topics and stuff that you're struggling on to fill in holes, I can pull those topics up and help you there. So if you need help on random topics or on the final exam, come in next Tuesday and Thursday. If you're good and you just want to work on your topics, I will see you some other time, because then we're done. Unless I'll see you on the final exam if you have to take the final. And class evaluations are up online. I think they're in your ComNet. I think there's a way to click on there. I know it's not Blackboard or anything else like that. So you can do your class evaluations. They actually do mean something. I know they know that I do a good job. Ryan Kennedy was in here, said I did a great job, but the evaluations really do mean something. And I actually do take the written feedback and do make changes based on the written feedback. So please do fill them out. And if there is a spot to put some written feedback, fill it out. I do read them all. So, all right. Any other questions before we start the chapter 7 and 8 review? All right. For the chapter 7 and 8 test, which is on Thursday, you will get a copy of the unit circle, and you'll also get a copy of the trig rules, the trig identity rules. It'll also include the law of sines and cosines. So you do not need to write those down. You will have access to both of those. It'll be double-sided, one sheet of paper.
We still have our old book.
I'm going to give it to you anyway, so doesn't make a difference, because it's going to be printed on the back of the last page of the test. So you do not need to have all those memorized or write those down in your index card. The proof problems will not be able to be verified. So they're going to say, prove this, and give you a blank page that you're going to have to write out your steps. Yes. Yeah, I would write that one down, because that's probably not going to be on the Huron's formula and stuff. Yeah, that's probably not going to be on there. All right, let's go through and do some. So I'm going to show you the problems similar to the way that I'm going to leave them on the test, because I'm going to cut a ton of the crap that Alex adds to these out. So you might not. So you have to be able to figure out what they're asking you to do as part of it. All right, so we got to consider triangle ABC. It's not going to be below. So you'll have to just draw a triangle real quick. Suppose that C is 67, A is 28, and C is 105. Solve the triangle. So you're looking for the other three portions of the triangle. So first thing I would always suggest to do is to draw a triangle. It doesn't have to match the angles or anything else like that. Just make it look like a triangle. Remember, label your angles and then your sides. The sides are always opposite of the angles. Then put the information they gave you on it. So C, that's 67, A is 28, and C angle is 105 degrees. All right, so draw your triangle, label your sides, put your information on it. Once you've got that, then you can start to make a decision. Okay, do I need to use the law of sines, law of cosines? things like that for the problem. What's the one determining factor if you can use the law of sines? What do you need to use the law of sines? Huh? You need a pair. That's the key. You need a pair. You need both of the same letter. In this case, I have both C's. So I can use the law of sines. If you do not have a pair, you need to use the law of cosines to find that pair. Okay? So in this case, I have my pair of C's. So we're going to use sine C over C, and we'll look for A first. Sine A over A. So I have sine of 105 over 67 equals sine of A over 28. So we can cross multiply this. Well, kind of cross multiply it. We don't even have to do the other side. Just going to multiply that side. So 28 sine of 105 over 67 equals sine of A. So, and then we have to do the arc sign to get rid of the sign, right? So on my calculator, I'm going to I can't write today, apparently. Okay. So on my calculator, so what I would expect to see, like at least some of those steps written out so that I can see that you know your process, and then on your calculator to find the answer. Okay. So don't go directly from this step to the calculator. I want to see what you've typed into the calculator. So sine -1. So you can type in that whole thing all at once into the calculator. I would suggest, if you're using Desmos, type as much as you can in without having to round and estimate. That's going to make your life a lot easier. So in this case, my angle for A is 23.8 degrees. Now, remember that when you're doing the law of sines, you can have a possibility of two triangles. So we've got 23.8, but you also could have the reference angle. That's the reference angle, the other side of it as well, or the coterminal angle. But in this case, that would be an obtuse angle, correct? So I already have one obtuse angle. I can't have two. So since I already have 105 degrees, I know there's only one triangle for this one. Okay. So if there was a second one, I would have had to find that other one and have two separate triangles for it. That is a possibility. Now that we got the 23.8 there, how do I find B? I'm going to subtract from 180. So yeah, I can't actually do the same yet. I don't have the other B. So I have to do the 180 minus. So 180 minus the 105 minus the 23.8. Somebody want to do that calculation real quick so I don't have to switch screens? I think 51.2 is right. Yeah. You might have made that an 8 instead of a 3. No problem. That's also, so like, that's actually why I want to see your work. Because like, if you wrote that down and then put 46 there, I'm like, oh, okay, you just typed in the calculator wrong. You know what you're doing, -1. However, if you just put 46 and didn't write down what you did, I don't know where your mistake was. That you lose more points for that. So the more work and stuff that you show on these on your paper, the better chance I have to give you points. So show your work. All right, so now we can find B by doing the law of sines again. Yeah. You're looking for, it says solve the triangle, you're looking for all the other three pieces that they're missing. So let's actually do this. I want to keep. So I've got C over sine of C equals B over sine of B. So 67 over sine of 105 equals B over the sine of 51.2. So B equals 67 sine of 51.2 over the sine of 105. Also, make sure your calculator is set up correctly. So in this case, we're using degrees, so make sure it's in degrees. So 54.1. How do we check to make sure that we did it right? What's the quick way to check it? Okay, does it make sense?
Yeah.
Why? Right. So the smallest angle should be with the smallest side, the biggest angle should be with the biggest side. So check that. That'll be a quick way for you to make sure you've done those right. Is it going to guarantee that you have the right answer? No. But it's a good way to make sure you didn't make a major mistake or switch something or switch a sign around or things like that. So, okay. All right. Any questions with that? Yes. Either one.
And Alex, like when you're doing these out, how do you round your initial finding for the side, like out for decimal places? That like,
Oh, for as long as you show me the work, I'll catch those little mistakes for rounding errors and stuff. In all honesty, I'm looking at this. Okay. I'm looking at your work to make sure you've done the steps correctly. If your answer's a decimal or two off of mine, you didn't screw up your work because your answer was way off of mine. So as long as your answer is close to mine and your work is correct, you're good. Okay. So yeah, Alex is a little pickier on that because it's a computer. It's got to be exactly what they want. When you're writing it out, I'm a little more flexible with that. So yes. No. Honestly, it's the same. The only difference would be you'd have taken the 23.8 and subtracted it from 180, which would have given you 157.2. Okay, I was off by one. It would have given you that. If that works in the triangle, you'd have just done the exact same thing for that second one. In this case, it doesn't because I have the 105. So
on the test, is it a possibility that
yes, it would be a possibility that happens.
so. Does happen?
You'd have two separate answers. Yeah, so you'd have the A would be two different answers, then your B's would be two different answers.
And that's it.
Yeah. You'd have basically two triangles that would work.
Side
No, this angle would be different, so this side would have to be different because this angle would be a lot smaller. So you would basically have to do it twice. Yeah. Honestly, it's just a matter of which problem Alex kicks out. So I don't know the numbers because I'm not coming up with the numbers. All right. Let's do this one. This one, because Alex does a very nice job at the pictures, I probably will put the picture for this one. Just because it's a cute picture.
Do we get the answer for the last one?
Yeah, it's the red ones.
All right.
The green one did not exist. Because the green one doesn't work. So the red answers are the answers. All right, so rover on Mars leaves station A and travels 22 kilometers due south. The sample rocks at outcropping B, then adjusts the course 51 degrees westward, travels 55 kilometers in that direction until it reaches deposit C. What angle with respect to due west could the rover have used to travel directly from station A to station C? So we're looking for that angle right there. So to find that angle, what do we need to find? We need to find angle A. So we need to find that angle right there. Okay. We know this angle is 51 degrees, but that's on the outside, correct? So what's the angle on the inside? 129. So that's 129 in there. All right. So do I have a pair? Good now. No, you're fine. I just didn't know if there was another one coming. All right. Do we have a pair? No. So we cannot use the law of sines. I need to use the law of cosines. All right. So what do I need to find? So I need to find a pair, which means we should find that side there. And then I have a pair. So we're going to look for C. So it's C squared equals A squared plus B squared minus 2AB cosine of C. Oh, you're right. Sorry, I put C instead of B. You're right. Problem's the same. Sorry, B. Okay, we'll change this to B's. B, C, C, B. There you go. All right. So we have B squared equals A is 55, C is 22, and then cosine of 129. And then I need the square root of that whole thing, right? And that'll give me B.
don't remember, but is that square? Okay. It's pretty square.
Yep. And I typed that entire thing into my calculator and I got 70.9. For B. So that's 70.9 there. Now, do I have a pair? Yes. So now I can find angle A. Where? 51. That right there? Yeah. So 180 minus 51 is 129. That's how we got the angle inside. So I've got sine of B over B equals sine of A over A. So sine of 129 over 70.9 equals sine of A over 55. So we've got the arc sine of 55 sine 129 over 70.9. So 37.1. So to the question on a test, there'll be the law of sines and law of cosines. It's just a matter of figuring out what you need to do for them. Because it's not going to tell you law of sines, law of cosines. You have to figure that part out.
A lot.
Oh, yeah, you're right. I have to subtract. You're right. Good catch. So, yes, that's 37.1. So I'd have to subtract it from 90.
Oh, right.
90. So theta, which is actually what I'm looking for, is 9 to 52.9. Good catch. All right. All right. Find the area of this triangle. You will not need Huron's formula. Yeah. So we need our height. So remember, area equals 1/2 base times height. My base in this case is 9. What's the height? So remember, your height is that piece right there, right? So we know that's 4. And we know this angle is what? 35. So how would I find the opposite? Yeah, so it's sine of 35 is h over 4, right? So h is 4 sine 35. So area is 1/2 9 times 4 sine 35. So 10.3 square feet. Yes. This is a right triangle. So if I know that's 35 and that's 4, and we're looking for that opposite over hypotenuse, is sine.
That's it.
That's it. That's the area of a triangle. All right, now we get into our trig identity rules and solving the trig problems. So that basically is chapter 8. This is the rest of the stuff, chapter 7. I don't think. All right, so find the solutions for this one. So first off, I don't have one function. That makes my life hard. So I've got to somehow change this so I have only one function. So how would you like to try to do that? Well, if I move it over, I could do that. But I still now have cosecant and cotangent, which I can't do anything with. I need to have. I can only really solve these if I have one, because then I can get one on by itself, and then I can solve for it, right? So right now I have two. So I somehow have to change one. Yes. Yeah. So it's like, remember the rule that we have that's with cosecant and cotangent is the cosecant squared x equals 1 plus cotangent squared x. So we have this rule. We have that. So if somehow I can use that, that'll make my life a little bit easier. So if I square the entire problem, basically, I have cotangent squared x minus 2 cotangent x plus 1 equals cosecant squared x. Come on, computer. It's gonna go off first. out. There we go. So you're squaring out this side. So you got the middle term. That's where the cotangent x comes from. So you're trying to use the Pythagorean identity to simplify the problem down. So now I can change my problem. So I can change my cosecant to 1 plus cotangent squared x. So I have cotangent squared x minus 2 cotangent x plus 1 equals 1 plus cotangent squared x. Now I no longer have cosecant squared. So now if you move everything over to one side, we end up getting negative 2 cotangent x equals 0. Yep, so cotangent x equals 0. So now x equals, so which values of cotangent equal 0? Yes. So we're looking for the ones that make cosine 0. So we have pi over 2 and 3 pi over 2. Now, we have to check our answers in the original problem to make sure they come out correct. So because we've done a bunch of stuff, we've squared things and things like that, so that can change our domains. So sometimes things will work on this part, but not in the original problem. So these are the only possible solutions that can work. So now we got to go check and make sure they will work. So if we plug in to the original problem, cotangent pi over 2 minus 1 equals cosecant of pi over 2. So cotangent of pi over 2 we know is 0, so this side's negative 1. What's cosecant of pi over 2? 1. So that doesn't work. Now if we try cotangent of 3 pi over 2 minus 1 equals cosecant of 3 pi over 2, negative 1 equals, and that equals negative 1. So that's the only answer that one.
So what is that identity again that you used in the very beginning?
Pythagorean identity. That'll be one of the ones given to you. And also one of the ones that you're using in your proofs. All right. Questions with this one?
And you just look at the unit circle.
Yeah, once you get the unit circle, then yeah, you can find those out. All right. Find the solutions to this.
So there's 4 or 5.
5. So one of the things that comes up is how do you know what to use? if you look at this problem, I have that in it. And just like the last one where I need to get them both to be the same, the terms inside have to be the same. So somehow I've got to change that 2x and that x got to be the same. So what rules do we have that allow me to change the 2x? The double angle rules. So we're going to use this one. So sine 2x is 2 sine x cosine x. It doesn't make much of a difference. Well, the problem that you're going to have if you move it over to the other side is you're going to lose information. So like if you move that over and you put because this is what you're going to try to do. If you do, which I think you're going to do, you're going to end up getting this equals 2 cosine x. Right? You've lost your sign, which is information. So what ends up happening is because you lose that information, you could lose a value that might work. So that's like when you're doing quadratics and stuff like that, you don't typically want, even if you have just x's, you don't want to put them on both sides and divide by the x because then you lose the x equals 0 term that's possible. And same concept here. So we have sine of x minus 2 sine x cosine x equals 0. I can now factor out my sine of x. So I have sine of x square root of 3 minus 2 cosine of x equals 0. Now I have the two things that I can solve for. I have my factored, so I can solve for them. So I have sine of x equals 0 and square root of 3 minus 2 cosine of x equals 0. So cosine of x equals negative square root of 3 over 2. So where is sine of x 0?
That's minus from the.
Yeah. Oh, you're right. Yeah. Yeah, that's what happens when you do multiple steps at the same time in your head. I moved and didn't subtract. All right, so when's sine of x 0? 0 and pi. And when's cosine of x square root of 3 over 2? And 11 pi over 6. This wants all solutions. So this one would be, well, actually, I would just write it as k pi, because it's every pi. And then pi over 6 plus 2k pi. And 11 pi over 6 plus 2k pi. Those are your three answers. No, and you just put 2 pi. So you'd have 0 plus or minus 2 pi, and then pi plus or minus 2 pi. Or plus 2 pi. You don't have to put plus or minus. So no, I wouldn't work there. And the k pi.
Yeah.
You need all three.
You can pi on top.
Well, that is k pi. You could write it as 0 plus 2k pi, and pi plus 2k pi if you want. Or k pi. They mean the exact same thing. So you would have 4 answers or 3, depending on how you wrote it. But that and the k pi is the same thing. And this one, unlike this one where we squared it, so we had to check our answers, because square changes possible answers. And this one, we didn't really change anything. We used an identity rule. So that's why we don't have to go back and check our answers, because we know every one of those answers are going to work. We didn't square things. We didn't subtract things. Like, we didn't change anything. So. Huh? Yeah, this one's the hard test. All right, so this one, they give you information about the angle. And you need to find a couple other trig identities or trig rules or trig functions. So we have cotangent theta equals -4/5. So which two? So remember, we're really looking for x, y, and r. So which two does cotangent give you? X and y. Which one's on top? X. So we have x is 4 and y is 5. Now, we know this is in quadrant 4. Notice I did not put my sign on my x and y yet. I know one of them has to be negative because I got a negative there. Which one's negative? The y. Okay. They have to tell you the quadrant to be able to figure that part out. Your radius will never be negative. How do I find radius? Pythagorean theorem. So r equals the square root of x squared plus y squared. 16 plus 25, square root of 41. So now sine of theta is what? No. What letters are assigned? Y over R. Sine is Y over R. On the unit circle, it's just Y, because R is what? 1. In this case, R isn't 1. So I need to have the R. So it's -5 over the square root of 41. I will accept that. You do not have to rationalize your denominator. And secant of theta is what? Yeah, it's R over X. The square root of 41 over 4. Those you might want to write down on your index card.
Every single one can do the test.
You have 2 nights, tonight and tomorrow night.
Goes for the opportunity to buckle down.
At 8 o'clock, I'm gonna sit down at the computer. But I'm not gonna get up until I get every single question right.
This is all.
This is all I'm doing tomorrow.
This is what I get for not doing the test over work.
All right.
We should pay for this test.
Yeah. And I'm giving you most of the stuff you're going to need. Yeah, you can use both sides of it.
I did not know that.
I didn't know that.
Remember.
There's no card though.
Every time I've had a teacher before, they're like, you can use a note card on the test. They say only use one side, so
Oh,
it's been like ingrained in me to.
Wait, did you say you can't type it?
no, you cannot type it. Handwritten. All right, next one. Prove this identity.
Here we go. Question 7.
Yes, this is question 7. 10. Every test has been 10 questions, and your final will be 20 questions.
I don't like that.
At least I'm consistent with those things.
So if we didn't have a whole final period, would the final only be 10 questions?
In past finals, my finals have been 15. So my finals are always a little longer. Normally,
20 questions.
huh? Yeah, it's 20 questions,
Yeah,
which you have
like
3
last-
hours.
Last year had like around 40 or so.
Yeah, it just depends. Like, I look at it as like you have to be able to finish it. So normally my classes are at night, so like people can normally spend a little time afterwards if they need a little extra time to finish the finals and stuff. So I've always gone a little bit over, but you need to be able to finish the tests. All right, prove this identity. So what are we gonna do? Yeah. So you can't do the Pythagorean identity if it's not square. However, if we want to use the Pythagorean identity, we have to square something. So which part do you want to square? And remember, whatever you do to the problem, you have to do to both parts.
What if you just put
So
-1?
remember, ignore that for the most part. We can't look at that side. So if you want to take this whole piece here and multiply it by tan x, you have to multiply the bottom by tan x too. So the question is that going to help me?
Change it to sine over cosine over sine over cosine.
Side of it. I probably wouldn't change this one to sines and cosines. So, all right. So what's the Pythagorean identity we kind of want to use? Yeah. Yeah, we kind of want to use that secant squared. Where's my screen? There's my screen. So we kind of want to use the secant squared x minus 1 equals tangent squared x. That one?
Yeah.
Okay. So if I multiply by tans, I have tangent x or tangent squared x over tan x secant x plus 1, right? Okay. That's an algebra step. Here's the thing. When you're doing your proofs, when you're doing them in actually, even in Alex, these things will work because that works. Sometimes you might try something and it doesn't work. And it's like, okay, I got to try something else. Sometimes it works. So he said multiply by 10. Let's try it. The key piece, though, is when you multiply by something, you have to multiply the top and bottom of the fraction by the same thing. Otherwise, you change the problem. Okay, so don't forget that part. All right, so then what's the next thing we're going to want to try to do? Yeah, so let's change that. So we're going to change that to secant squared x minus 1 over tan x secant x plus 1. And that's a Pythagorean rule. Okay. Now let's factor. Let's factor out the top. So we're gonna go up here. So I have secant x minus 1, secant x plus 1 over tangent x, secant x plus 1.
So we can do something.
So that's an algebra step. And we can cancel those out. That's an algebra step. And I'm done.
This one was wild.
I'm trying to love this now.
I don't.
The actual way that the book that Alex did it, and that we've actually done this problem before, you multiply by its conjugate pair. But in essence, it's the same thing.
It's like the same number of steps too.
Yeah.
Is there another way to do this one?
Yeah, multiply by its conjugate pair. Multiply by secant x minus 1.
You would have still been able to still calculate.
You still would you're still using that rule. So that's the thing with proofs, is that you don't always have to do it the exact same way. Sometimes a different method works. Yeah, tell me what you did in that step. That's the one thing that the difference between a proof and a solving of something is you have to tell me why you're doing it. You can use the A, P, D for double angle, things like that. That's fine. You don't have to write out the whole word. If you want to, it's fine too.
Yeah, I did that too.
But
I wrote
tell me,
DA for double angle.
Yeah, that's fine. Just as long as I can look at your notation and figure out what you're talking about, we're good.
I also circle it. So
Yeah, that's fine. Let's actually. I'll do one more of these. This is still question 7. I wanted to do another one of question 7.
You said there's only 2 versions of the test. You've probably seen some of the questions on the.
Oh no, there's hundreds of versions of the test. I can actually print out 5 different versions of the test. But
oh, we're trying another one.
yeah, I wanted to do another one of these. I haven't solved it yet. But what did I do? Sometimes looking at what you're going to can help you. So I have sines and cosines I'm starting with. So I somehow got to change sines and cosines to secants and tangents. So let's look at those in sines and cosines. Well, it's 1 over cosine, sine over cosine. Cosines in the bottom is the same, so I really want 1 minus sine x over cosine x. If I can get to that, then I can easily get back to my answer. So how would I change this to that? If you think about what we just did in this problem, it's actually basically the exact same steps. So you're going to multiply by either cosine x actually, or 1 minus sine x. We'll do this one with the 1 minus sine x.
So wait, is that the next one? The blue writing?
No, the blue writing is like, so sometimes when you're looking at a proof, like if you just look at this and try to get to that, you might have no clue where to start. Okay. So if the blue over here is my thoughts on looking at that problem and changing it to sines and cosines. So then you have an idea of where you're going and where to start to do your proof. Okay. So you can't use that side to do your proof, but you can use that side to start getting ideas of what to do. All right. So now I've got it to this and like, oh, okay, I can see how I can get from there to there. And then we just go backwards. So I'm multiplying by 1 minus sine. So I have cosine x, 1 minus sine x over 1 minus sine squared x.
So if you put sine x minus 1, that problem.
Yes. So those both are algebra steps. Now I'm going to use the Pythagorean identity. So cosine x, 1 minus sine x over cosine squared x. That's Pythagorean. And now I'm going to get rid of my, that's an algebra step. And now I'm to there. Now split it. That's an algebra step. And now Alex won't let you do that. I will. Just tell me which both that you use the reciprocal and the quotient rule for it. So that's the thing with proofs is that they're intentionally difficult to figure out where you're going. So sometimes you need to look around to figure that out. And that's why I looked at that side before to figure out like, okay, how can I get there? So, and it's not wasted work because eventually you're going to get to a point where that exists. And then you have it.
Wait, so you can separate the one from the.
I can separate if the denominator, if there's a one piece on the denominator, I can split it. It's just like 1/2 and 3/2 is 1 plus 3 over 2. You just combining the bottoms. I can split it that way. You can't if it was reversed, if it was cosine, like the first problem. I couldn't write cosine over 1 and cosine over sine. So you can split the numerator, you cannot split the denominator. All right. What's the next question? All right. I'm actually going to do question 9 next because question 9 is another proof, and then I'll do 8 and 10. This was kind of in the proof thing. All right. So what are you going to look at in this one? Somewhere I need to use a double angle rule.
Will we ever need to do the power reducing ones?
No, I did not put that on the test. All right, so what do we want to try? Okay, let's try that. So secant squared x over 1 minus tangent squared x. Okay. That's a Pythagorean.
Can you separate the one from
No, that's the denominator. So this might be one of those that changing the sines and cosines might start to give me some help. Yeah, let's try to change all these to sines and cosines. Let's see if that helps me out a little bit. All right, so secant squared x is 1 over cosine x squared x, right? And then I have 1 over 1 minus sine squared x over cosine squared x. So that's
What if you put that
reciprocal and quotient rule. So if we did 1 over cosine squared x minus sine squared x,
No, I changed the top to 1 over cosine, and I left it there. So I got 1 over cosine, 1 minus sine squared of x.
you could have. It kind of is messy, and it doesn't help with you get to the next step that I just did. So everybody see how I went from here to here? I just multiplied the denominators. Cosine x times, or cosine squared x times 1 is cosine squared x. Cosine squared x times sine squared x over this cancels the cosine x. That's how you get sine x. So yeah, I did the reciprocal and quotient rule to get from there to there. And then I just did algebra to get to that step. All right. Do I have something to work with the cosine squared x and the sine squared x? What? Yeah, that's a double angle rule. And then that is that by the reciprocal rule. I remember proofs. QED. Means you're done in Latin. So sometimes switching to those sines and cosines is the best way to go. The crazy thing, so I'm going to show you. This is what Alex did. So it did the Pythagorean, which was he did. It did the quotient identity for the bottom, which is fine. Then it got a common denominator. Then it flipped the fraction over. Then it did the reciprocal. Then it canceled out. It was like it did like 5 extra steps for what, like just doing the quotient reciprocal. Like,
Alex would have said, multiple ways, right?
Yeah.
so
Yeah.
that makes sense.
The only difference is closed instead of switched to screen. The only difference is it won't let you do the two rules at the same time. So it wouldn't let you do the R and the Q at the same time. So you'd have had to do secant squared x on top of this, and then done the 1 over cosine as a second step. So you'd have had to do this as 2 steps. But from that step to that step, you should have been able that you'd only have to do once. Because that literally is just an algebra step to get to there. So. But that's also the reason why, like, sometimes writing them out, as long as the step you do is mathematically correct, you're fine. So when you're writing them out, as long as what you did is mathematically correct, you're going to get a credit for it. And as long as you tell me what you used in that to go through those steps, you're going to get credit for it. So if you do 2, just like I said, like reciprocal quotient, you use those quite often at the same time. So you can put those together. That's fine. All right. Last 2. It's the sum and difference and quotient, the product rules.
Oh, you can break it down.
Yeah.
The number 8 or number 10?
This is 8.
I'm not used to those letters.
It's alpha and beta. It's just Greek letters.
They don't really affect the problem.
No. It's no different than X's and Y's. All right. So we've got cosine of alpha and tangent of beta. Again, you can literally, if you want to do, you can say tangent of x plus y and just change this to x and change that to y. It doesn't matter. So that's totally and utterly up to you in that case. Possibly, yeah. Or parts of it are going to be. All right, so let's figure out what's the rule for that. And yes, I'm giving you these, so you don't necessarily have to memorize them. I just have to find the sheet that I want to use. This is a possible sheet that I'm going to use. It just does. They use those symbols. So we want the plus. So tangent of A plus B is tangent of A plus tangent of B over 1 minus tangent A, tangent B. So I need to find the tangent of A and the tangent of B. Good news is we already have the tangent of B.
Tan A plus B, are those the same A and B?
Yeah. Yeah.
I'll make sure they're not different.
Nope, they're the same. I just didn't feel like writing the Greek letter.
Also asking because you did change the Greek letter.
Well, yeah, it doesn't. That's what I'm saying. It doesn't really matter as long as you are consistent. Like, don't change it to cosine of y and tangent of x. Like, don't change those. Like, just be consistent in how you change it. It doesn't really make much difference. We've already got that one, so I don't need to worry about that one. I do need to do this one though. So cosine of A is that. So that means x is 15 and r is 17. So I need y. Because I'm using tan B. I don't need cosine or sine, so I need a tan, and I've got it. So I don't need to find it since they gave it to me. Saves me some work. So we need to find y, so I can find x over y. So Pythagorean theorem, so it's the So y is the square root of 17 squared minus 15 squared. What's that? 340 something? Hold on.
89 minus 325.
Yeah. 64, so 8. And since it's in quadrant 1, it's all plus.
Because of the block that we did.
Huh? It's in quadrant 1.
Yeah.
Yeah, so that's why it's a y.
Yeah, the what? Well, I think
Yeah.
it's square.
All right, so y is 8. So tangent of A is 8 over 15. So now we can just plug in our values for these. So I have 8 over 15 plus 4 over 3, 1 minus,
Oh, you need it right.
huh?
You need it.
No, because you actually, this is what tangent of A is,
Oh, okay.
not the angle. That is what tangent of A is. So we don't need to find the tangent of it because that is actually what it is. So. And you can type that exactly into into Desmos. And just click the little button it gives it to you as a fraction. So you don't have to do a million steps to simplify your fractions.
So that's the answer.
84 over 13. So the answer is 84 over 13. Okay. So it's just going to give you one of those, and you just have to use the rule and find the pieces to go into it. All right, last one. So use the product to sum formula to rewrite that as a sum or a difference. So this one is cosines. So there's the cosine rule. So it's the subtraction first.
Those weird looking letters.
It's
So
just, it's
we just program as A and B.
yeah. And so I'm using this probably is the sheet I'm going to use, and that's the symbols they use. I haven't totally decided. I might choose a different one, but it just happened to be the first one that I pulled up. So, but again, the symbols don't matter. You can use X's and Y's, A's and B's, whatever letters you want. A lot of times when you're dealing with angles, they typically use Greek letters. So that's why in this one, they're using Greek letters. So the first one says subtract the two angles. My two angles are 5D and 3D. So that means subtracting them would be 2D. plus the next one says add them. So cosine of 8d, all divided by 2. That's it.
Yeah, do it more.
Nope, that's it. Yeah, it's literally just remembering the rule, looking at the rules.
Nicest question.
I know.
So
All you do is-
I'm giving you the rules.
Where do we get the 2 and 8 from? Oh,
Add them and subtract them.
that
This
is.
test is gonna be awesome.
Wasn't he saying like 5 minutes ago, I'm going to spend the entire next 2.5 days doing nothing but the trig test?
And here I was thinking I might suck at some of these, but looks like this one I might not.
Yeah, so it's like not all of them are bad. It's just, yeah.
It's just some of them.
It's gonna be fun.
Actually, this sheet better. I like that sheet better, so I'll use that one. Other than that, so your test is on Thursday. I'll have them back to you on Tuesday. As long as you're in, if you're in the A's and you get an A on this one, you're exempt from the final. You just have to finish your topics and outs. So
If we get a B or under, we'll still do the final, but
yes,
which is fine.
which in my mind would be stupid. If you got an A in all your tests, you better get 80% of your topics done. I would much rather you do that than take the final. Like that would be a dumb way to have to take the final exam. But it is an option. So other than that, I will see you guys on Thursday.
Well,
I'll try to be, I should be here around noon. So if you want to come a little bit early to take the test, you can come in a little bit earlier.
that reminds me, how is the final adequately grade exactly?
What do you mean? The finals, 25% of your grade.